Here is 5.3 Algebra 2 homework. It is a worksheet. It has 16 questions on it. It says worksheet 5.3. You are going to find the real and imaginary zeros by factoring. Question number 1. It's the sum of two perfect cubes. So this factors to be x, x, x. 4, 4, 4 is 64. So this factors to be x plus 4. We take one of each of these along with this sign, and then these two are squared. Change the sign, minus 4x, and the last sign is a plus sign always, and multiply those two. So one of your zeros is negative 4. How do you get these two zeros? What you have to do is, I will complete the square here. You have x squared minus 4x plus 16. Set this equal to 0. Subtract 16. Half of this in square, you're going to add 4 to both sides. X minus 2, quantity squared equals negative 12. Take the square root of both sides. Plus or minus, this is going to be 2i root 3, and add 2. So you're taking the square root of both sides here, and I just simplified it and added 2. Number 3. I believe this problem says 3x cubed plus 3x equals 2 plus 2x squared. So what you're going to do is bring this over to this side. And bring this over. Now I would do factoring by grouping. I'd pull out x squared. You're left with 3x minus 2. And this is 3x minus 2, so it's 1 times 3x minus 2. So you have 3x minus 2 times x squared plus 1. So one of your answers is 2/3, and this one you're going to set this equal to 0, subtract 1, square root of both sides, and you get plus or minus I. So the three answers are 2/3 and plus or minus I. Number 3, this one you can first factor out a 2. And then this is the difference of two perfect cubes. It's going to factor to be x minus 5, x squared plus 5x plus 25. Now, one of our answers is 5. And for this one, I would use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Why would I not complete the square here? Because this is an odd number. So it's negative 5 plus or minus root 25 minus 4 times 1 times 25 all over 2 times 1, which is 2. So you get negative 5 plus or minus root 25, and this is going to be minus 100 over 2. So coming over here, you have negative 5 plus or minus root negative 75 over 2. And this is going to be negative 5 plus or minus 5i root 3 over 2. And there's nothing to cancel out. So there's 3 answers, 5 and then these 2. Number 4. This one, you're going to get the x cubed to the other side, so it's 3x to the 4th. I'm going to put minus 24x cubed over on the left side, and then plus 36x squared equals 0. Now I know I can take a 3 out and an x squared. So let's GCF a 3x squared. You're left with x squared minus 8x and then plus 12 equals 0. Now, what times what is 12 but adds to be negative 8? Negative 6, negative 2. So this one has 3 real zeros. This one is 0, this one is 6, and this one is 2. Next one. This is a trinomial, and it has x to the 4th, and we can probably factor this one, it seems. For x to the 4th, x squared times x squared. What times what is positive 11 but adds to be negative 12, and that would be negative 11 and negative 1. Now you would set each of these equal to 0. Add 11, square root both sides, and you get plus or minus root 11. And for this one, x squared equals 1. Square root both sides, and you get plus or minus 1. So there's 4 real answers. Number 6, this is the difference of 2 perfect squares. You get x squared minus 9 times x squared plus 9. Set each of these equal to 0. X squared minus 9 equals 0. Add 9. Square root both sides, and you get plus or minus 3. And this one, when you take the 9 over to the other side, it becomes a negative 9. And when you square root both sides, you get plus or minus 3i. The next one, number 7, we can try to factor this one. Let's see. We're going to have x squared, x squared. What 2 numbers multiply to give you 36? Well, 6 times 6 is 36, but it's not going to give you a negative 5. How about 12 times 3? That's 36, but that's not going to give you 5. How about 9 times 4? That's it, 9 and 4. A 9 and a 4, 9 and a 4 will give you, if we put the negative 9 here and the positive 4 here, we'll get negative 36, but it'll add to be negative 5. So now you're going to set each of these equal to 0. X squared plus 4 equals 0, and x squared minus 9 equals 0. This is easy. It's going to be plus or minus 3. In this one, when you subtract 4, you're going to get plus or minus 2i. Number 8 is another one I believe we can factor. You get x squared. We're going to put a plus 4 here because we want 4 and a minus 1 here. Because these two will add to be 3x squared. So your answers for this one are plus or minus 1, and this one's going to be plus or minus, again, 2i, just like the last problem. Back page. This one says, it's hard to read, it says, I believe, 4x cubed plus 2x squared minus 20x equals 0. I see a 2 and an x I can GCF out. So you're left with 2x squared plus x minus 10 equals 0. Let's try to factor this one. Maybe it's factorable. 2x times x, and we need 10. 5 times 2 is 10. If we did a 2 here and a 5 here, we get 4. And so we want the positive here and the negative here. So 5 times negative 2 is negative 10. These give you negative 4, positive 5 is a positive 1. So your answers for this one are 0, negative 5 halves, and 2. For number 10, 8x cubed minus 13x squared. I'm going to bring minus 6x and set this equal to 0. The only thing I can take out is an x. So we have 8x squared minus 13x minus 6. Now, if you wanted to see if this is factorable, I would definitely try the AC method. So what you would do is say, okay, what two numbers multiply to give you, we want negative 48, but we want them to add to be negative 13. So I start with 1 times 48, 2 and 24, 3 and 16, and there it is right there. These two, 3 times 6 is 48, and we can get these two to add to be negative 13. So 3x and 16x. So you're going to rewrite this as 8x squared. Now we're going to want a negative 16x, and we're going to want a positive 3x, and then minus 6. So for these two, I'd pull out an 8x, and you're left with x minus 2. And here I'm going to pull out a 3, and you're left with x minus 2. So you have 8x plus 3 times x minus 2. And don't forget you have an x out here that you GCF'd out. So your zeros are x is 0, x is negative 3/8, and x is equal to 2. Number 11. This one you're going to factor out an x. You get x cubed minus 1. And this is the difference of two perfect cubes. You get x minus 1 times x squared plus 1x and then plus 1. So the two zeros so far that we have are 0 and 1. And what you're going to want to do for this is use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So you have negative 1 plus or minus 1 squared minus 4 times 1 over 2 times 1, which is 2. So it's negative 1 plus or minus, we have 1 minus 4, which is negative 3 over 2. And all you have to do here is take out an I. So the answer would be negative 1 plus or minus root 3 I over 2. And don't forget x equals 0 and x equals 1. These are your answers. Number 12. I'm going to try to factor this one. What times what is 16 that adds to be negative 10? We have x squared and x squared, and I'm going to say negative 8 and negative 2. Those two multiply to be 16 and add to be negative 10. So what you're going to do is set each of these equal to 0, add 8, square root both sides, and you end up with x is plus or minus 2 root 2. And for this side, x squared minus 2 equals 0, add 2. Root both sides, and you get plus or minus root 2. Number 13, you'll get a 0 on one side, x to the 4th minus 25 equals 0. This is the difference of two perfect squares, x squared minus 5 times x squared plus 5. Set each of these equal to 0, x squared minus 5 equals 0, add 5, and square root both sides. So x is plus or minus root 5. This side, you're going to subtract 5, square root both sides, and you get plus or minus root 5i. Number 14 is the sum of two perfect cubes. 3x times 3x times 3x is 27x cubed, and 1 times 1 times 1 is 1. So you have 3x plus 1, that's your binomial, and then your trinomial, you're going to take these two and multiply them together, 9x squared, switch your sign, minus 3x times 1 is 3x, and then plus 1 times 1 is 1. So one of your answers is negative 1/3. That's easy. This one, I would use the quadratic formula. It's negative b, so 3 plus or minus b squared, 9, minus 4 times 9 times 1. All over 2 times 9, which is 18. So we have 3 plus or minus, okay, we have 9 minus, what is 9 minus 36 is negative 27 over 18, which this is going to be 3 plus or minus 3i root 3 over 18, and you can cancel a 3 out of all three of these. A 3 goes into 3 once, and 6. So your answer here is 1 plus or minus 1i root 3 over 6. Now you don't need this 1, you can just say I root 3. 2 more. This one says 2x cubed plus 7x squared. I'm going to bring 6x over, make it negative 6x minus 21. It appears that we could factor out a x squared. Here, let's try this. And we are left with 2x plus 7. And for this one, we're going to take out a negative 3, and we're left with 2x plus 7. Excellent. So these two are the same, so you have 2x plus 7 times x squared minus 3 equals 0. This answer is negative 7 halves. And this answer, if you take x squared minus 3, set it equals 0, add 3, square root both sides, you get plus or minus square root of 3. And the last one, number 16. I would pull out a 2. And this is going to be the sum of 2 perfect cubes. You get x plus 3, and then x squared minus 3x plus 9. So one of your zeros is negative 3. The other one, what we have to do is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times 1, which is 2. So we have 9 minus 36, which is negative 27, so it's 3 plus or minus negative square root of negative 27 over 2. So this is going to be 3 plus or minus 3 root 3, there's an I, over 2. And you can't simplify anything. So we have these two answers and those two. And the problem is done. Homework is completed.